This is a video about the Linrad noise blanker. I will start by showing how it behaves on a very old recording. It's from the Leonids in year 2001. And it was presented first on this page, and then about 10 years later I wrote this page about it. And now you should be able to see the URL from this. On this page, the second one, you can download the wave file and also the parameter files for calibrating the noise blanker. This is the antenna I was using for the recording in 2001 during the Leonids. Only one is still in place. There was a second one at the top of this tube, vertically about 1.5 meters, maybe 1.3 meters or so. And half of it is here. It was 16 years ago now. Here I'm running the file that you can download from the second URL. I'm using Linrad 04.12, which is the latest stable version at this time. The noise blanker is disabled, you can see here, and we can hear the local station SM5 FRH, but not those stations that he is working. And you can see interference changes with time. Here it is almost gone for a short period, and here it was stronger. So there are changes on how the discharges on this faulty isolator behaves. And you can see on the S meter also that sometimes the signal is, well, here you had the case where the interference is almost gone, but Tobbe was speaking, so we don't see that on the S meter. Anyway, now I switch on the noise blanker, the dumb blanker. That's with the yellow box here, and I make it manual. And you see it behaves very badly. That's because the threshold, the blanket threshold here is far too low. You can see everything gets red. That's not okay. So I have to bring this up. And you can see this isn't even enough. I have to go very high, like that. And when I bring the blanker level down, something goes wrong. So I have to bring up this red bar, maybe like that, to get normal operation. And now we can start to hear the other stations. I will have to change the color scales of the waterfalls, maybe 20 dB, 35, I make it 20, that is 15. And also in the baseband, 15. And then I can look for what is optimum here. Now the time constant for selecting whether a signal is strong or weak depends on averaging. For the spectrum, the main spectrum here, there are two time constants. One is here, averaging 6 spectra and taking a decision based on that. That is a fairly noisy signal. And then here, averaging 42 spectra and taking a less noisy signal and take decisions on that. And those two are for the blue bar here. And then the red bar is from the final waterfall on which the blanker has been applied. And now averaging is very small, it's only 3. I can make it bigger, let's say 20. Then there is a much better statistics on the signal that is used to determine what is strong and what is not strong. And you can see even this signal here, which isn't much visible here, gets red occasionally. And now I switch off the dumb blanker and then switch on the smart blanker. And you can hear something isn't good. I make it manual. And it's obvious something is not quite right. So I change from 04.12 to the latest version, which is still only on the repository. Now things are better. There have been problems in Linrad several versions back that I didn't notice and nobody complained about it. It has to do with problems due to multi-threading, some timing problems. But now I have corrected those, I think. And you can hear it sounds quite good now. I can try the dumb blanker instead. And I cannot have the threshold as low as this, I think. You can see this red area is now this area here, the white or the red here is expanding. So I have to make this threshold a little bit higher. Maybe something like this. And I can look at the oscilloscope, move this away. And click here for the oscilloscope, which you can see here. And I have to click the gain, minus, to bring the things down to a reasonable level. If I remove the blanker now, you can see how the pulses look. And I turn down the gain. Here is the amplitude of the pulses, and I go up one step. So we have the pulses at about 3 centimeters on the screen. I can click on the L here to draw the curves as lines. On this computer is no problem. Long ago the graphics cards were slow for this, so I have this option. Bring on the blanker, the dumb blanker, and you can see how it cuts holes to remove the pulses. But if I make the smart blanker and remove the dumb one, you can see how nice things look, and there are no pulses for the dumb blanker to take care of. That is because of this clean cut situation. The only interference is that power line noise. There could be some other noise sources, then it would be good to have the dumb blanker also at a similar threshold, or even a little bit higher, something like this. So the important things are the time constant for the waterfall. I can go here and put, let's say, 3 again. Then there is a different statistics for deciding what is a weak signal or a strong signal. And then the level here, what should be strong and what should be weak. That depends on circumstances, and I will show later on with the original recording, which is in 2 channels, because there was 2 antennas. What you see now is the average of both antennas. I will look at the station up here. Honolulu Whiskey Tango something. And you can see the noise floor goes up and down. We have fairly bad situation here at 0048 or so. I will focus on that. Press F. 0.0.46 and then run until 0.0.15. So I will repeat that time sequence over and over again. And you see here. And then look for what is the optimum in this situation. Switch off the dumb blanker. And you see it doesn't make things better. I bring up the level of the clever blanker. And that helps. Setting the level too low introduces noise. Trying to subtract pulses that are really very small will probably be more likely to add noise than to remove anything. So look for the position here is the level where pulses disappear. From here to here is 20 decibels. I'm 20 decibels above the noise floor. So I go down to 10 decibels above the noise floor that we had after removing the pulses. That's something like this. And that is fairly optimum. And then one has to worry about the width of these red structures, but that will be more clear from the recording with 2 antenna signals at the same time. I now add the dumb blanker at a similar, you see, just adding it causes noise. Adding it with a appropriate level makes no difference in this situation. Now I'm playing the original 2-channel recording, the first 40 seconds of it, which is the first 40 seconds of the recording in single channel that I played previously. And you can see here are 4 noise channels and 4 channels for strong signals. And the noise blanker is not enabled. I have adaptive polarization, which isn't very meaningful at this way of using Linrad. Anyway, first I switch on the clever blanker here, smart blanker.
Yankee Tokyo 1, Victor Victor, 59 West, Lima Alpha. Yankee Tango 1, Victor Victor, 59 West.
And I have to increase the gain of the waterfall. 0, it's by 20 dB, because that's the gain I get by removing the noise pulses. And I prefer to use manual on the level. Automatic is for situations where there are more and complicated patterns of strong stations. And now I go for the IV3 station we had here. And you can see that the adaptive polarization is fairly successful in making the green strong and the red weak. And this is the polarization. It suggests 45 degrees, but it means that the signal is equally strong from the 2 antennas. And whether it's elliptic or linear, that is the phase angle between the antennas. So I should, a straight line here on the polarization graph means the 2 signals are in phase, and the circle means out of phase. And I can play a little bit with the threshold. And it's very insensitive. Doesn't matter much. And bring the thresholds up a bit. And it doesn't matter much either. I need a more difficult situation than this to observe any such effects. Well, now with 2 channels I can demonstrate other interesting things here. I click somewhere where there is no signal at all. Here there is only noise. And then I switch off the noise blanker, like that, and allow Linrad to adapt polarization. As you can see, the phase angle is very close to 0. I get nearly a straight line in adaptive polarization. And now turn to fixed, like that, and then I go for the orthogonal polarization. That's by clicking the Q here in the polarization graph. So now the interference is gone by phasing and not by use of the blanker. I enable the blanker now, And to see on the waterfall, well, you could hear that enabling the blanker increases the noise by about 6 dB. So subtracting noise pulses adds 6 dB to the noise background, but of course, well, I remove the blanker again. The noise level goes down by about 25 dB by use of the blanker, while it goes up by about 6 dB due to the blanker. So there is some additional improvement that could be done here by having a better calibration on the system, or maybe by other ways. One possibility is just to increase the blanker threshold. And you can see here that the green track doesn't start to decrease until the red track has degraded very much. So the threshold level does not give us any tool to improve. And again, I go back for the and now I'm listening to this Italian station with the linear combination of antenna signals that makes the interference 0. And I can remove the noise blanker. And here we can hear quite well. But only those stations that don't come in the same direction as the noise source. And to see what it means, I enable the blanker again. And you can see that the Italian station is stronger in the polarization. Well, it's equal. But I'm losing 3 dB or 4 or 5 by listening in the direction where the interference is 0. So phasing is not a very good idea in this situation, but it could be an extremely good idea in other situations where the noise and the signal come from different directions. And I now try with the dumb blanker. Well, I first go out on the noise floor like that, and then enable the dumb blanker. And here you can see that the dumb blanker is overused. Removing 30% means I have to increase the level here, the blanker level, maybe something like this. Now it removes 6%, and I disable the blanker. And here you can see that the blanker does not add interference. I enable it. And the green track stays, but the red track is maybe 10 dB above the green track. And we can see here that the level is a little bit too low. I have to go to this situation. But still, in this situation the dumb blanker does a better job. I can enable the smart blanker at the same time. And you could hear the noise comes. Means subtraction is far from perfect. And we can look at the oscilloscope function. Here are the pulses, and triggering is on this point here. And I increase the gain of the oscilloscope by clicking here. And then I enable the blanker. Again, the smart blanker. And set a suitable level for it. And it's obvious that we have some structures that come in this region where the pulses are. And that's some kind of wideband noise that is added because the calibration function is not right, or because I'm not doing the subtraction of noise pulses properly, or maybe something else. I can change the selection of what is a strong signal, for example like this, making everything a weak signal. And then in the power you see, of course, the SSB signals, but when they are absent, the noise is probably a little bit lower. This is all rather involved, not very critical, but if you want the very best, it's necessary to play with all the parameters that affect performance. Now, this is Linrad 04.13 pre-release. It has all those boxes here. They affect how the blanker operates. And not much. I can click on them and you wouldn't see any difference, probably. It mainly affects how the strong signals are added or removed when the signals go away again. So it does, these values here may relate to values here and also the threshold. And there is another thing, if I go on the strong signals, well, there is some situation where the signal you listen to will be routed outside the blanker. And this may be good for fairly weak AM stations when you use the smart blanker. Because applying a blanker to an AM station means that you make a keying click from the carrier. That's not what we want. The smart blanker subtracts pulses also from those signals that are routed outside the blanker if the signals are not too strong. This is a recording by ON4KHG. The interference is a low energy lamp. It produces noise bursts, and you can see they last about this time. And it looks like white noise. Enabling the smart blanker here, as I can do, makes no difference at all, because these are not impulse noise. And other noise pulses you see are not typically noise pulses either. They are wider. I don't know why. Anyway, the smart blanker is useless here. The RMS signal to noise ratio for the weak signal that I found in this recording is maybe 1.5 dB. And you can see here, listen carefully when it comes back. It says COM during that time, and that's where we see the stronger RMS. I switch on the dump blanker here, and you can see it cuts to 0 many points, but the white noise is very close to the level of the interference noise. So, well, anyway, at this time I cut away 6% of the data, and the white track here shows that the peak noise in the baseband has gone down by 2, 4, 5 dB, approximately 5 dB, while the signal to noise ratio of the signal has increased to about 2 dB. It's a very small difference, and if you listen carefully at this time where it should say COM, well, its zone comes back to that time. It's a short recording only, playing over and over again. And it's very difficult to hear. A slightly higher threshold, now it's 2 or 3% removed, may be better, maybe not. It is not very critical, but removing more than this is going to degrade. This is from a recording by KA1ZE. 2 channels, some ugly interference. You can see here a single very strong pulse, and then surrounded by many much weaker pulses. I can increase the gain of the oscilloscope here 2, 4, 8 times. And then you can better see the power line noise that comes here, and this dominating pulse that comes one by one. I'm running Linrad with no special adjustment and without the blanker now. I'm using adaptive polarization, and since the interference is stronger than the desired signal, the adaptive polarization will adapt to make the interference as strong as possible. And you can see here that the SSB signal is visible in the red track, which we don't hear. So I click to fixed polarization, and then in this phasing graph I click on the Q. And now listen in the orthogonal polarization. And you can hear that the AGC makes some unpleasant things. I can stop that by putting a bigger number here, I think. Maybe even 6. Although that is not really what I want in this case. I go back to 2 and instead enable the blanker. And maybe also the dump blanker. And as much as 2% is maybe not what we want. I go up a little bit. And now, since the interference is gone, I can enable the adaptive polarization again to optimize signal to noise ratio. And the signal is weak. So it takes some time, but after a while you can see that the signal dominates in the green track and that the red track starts to be much smaller. So now, after a long enough time, we have optimum signal to noise ratio and no interference because the blanker has taken care of it. And this is fast AGC, and that is not really what I prefer normally. Or even just turning down the RF gain. And it's hard to hear what he is saying. This morning, something. Well, this works pretty well, I think. I mean, the noise is gone more or less completely. And this is the main spectrum. There is no other signal to watch for in this section of the recording.